Hey, hello there. So this week I'll be solving some linked list related questions. So to start this week simple, I got this question 206, reverse linked list to start with. So it's a relatively simple question. So the question is as simple as just five words. Reverse a singular linked list. The singular linked list is basically a sequence of nodes object. Each node will have a pointer that points to the next node in the sequence. So to reverse this, we are not really changing the nodes value, but rather to change those pointers. So instead of having 1 points to 2, 2 points to 3, so on and so forth, we will have 3 points to 2, 2 points to 1. So change all those directions. And this question also asks us to implement this in both iterative and recursive methods. So if you ask me to choose one from two, I would rather go for the iterative one, because the iterative one is constant in space, and also it's slightly easier for me to think about this solution iteratively, because I can enumerate over some example myself, manually solving that. But for recursive methods, I have to think recursively. I sometimes got tricked inside the loop. So yeah, if you ask me, I would definitely prefer iterative over the recursive one. Not to mention the recursive also has the call stack is linear with respect to the number of nodes. So you have to somehow go back all the way towards the tail and start to actually doing the reversal and backtracking backwards. So the call stack is going to be linear with respect to the length of the linked list. So it's not space efficient as the iterative approach. So yeah, so with that said, let's jump right into how to solve this iteratively. Obviously, we start with currently, I like to use the variable traverse to indicate I'm looking at one of the node there. So the first thing that I want to do is to have this pointer actually points to a null pointer, right? Yeah, here. So but if I have this arrow points to a null pointer, I will lose the ability to keep traversing through this linked list, because I will never know the node 2. I'll have no way of getting to the second node there. So the first thing is to grab a pointer to next. So I'm just gonna start to draw this to make it looks like animation, and then I will do the rewiring. That's changing this link to have it points to a null pointer. So I'm gonna move this to make it align a little bit better. This is the initial. The third thing then is to move my traversal node to the next node, because I'm pretty much done with the node 1. It's already looking like the final result there, so I should advance myself to this next. So since that I already have a pointer to the next, I can just change the traversal to go to the send location that's next. That's this is actually the initial case. It's a little bit on the boundary case, because we are handling the node points to a node pointer. Then we should pretty much just repeat this. We will move this next to 3. And then what we need to do is to actually have 2 points to 1. So rewire the link. So now we notice that we actually need something to point to the previous node that we just done the rewire. So so that means in the very beginning we should have a null pointer here, and initially we will have the previous variable that's pointing to this null pointer. So that when we do the rewire, it's always pointing to the from the change the next the pointer from this current traversal node back to this previous node. Okay. And also in the advanced stage, we should move this previous pointer from the to the location of the traversal. So that's that. Yep. So after we done the rewire, then we have to do the advance again. Which is just to put the traversal to points to the same next, and move the previous to the location where the previous traversal node is. So we notice that the order of advancing the nodes here is to move the previous first and then move the traverse. Otherwise, if we move the traverse first to the location where next is, the previous will not be able to move to that location. So just to make a quick note here. So with this, it's pretty much done the generic case in the middle of the linked list. Here is the very beginning. Then we just work pretty much one last example about getting to the tail, and we should be able to finalize everything. Obviously, if you on a whiteboard, this could be much faster. Just typing here to make animation, it's painful. So let's say that we currently at we're gonna be at some kind of a position, right? Here, 5. So just to simplify this a little bit. So if we find that no, we don't have list link anymore. That's when we pretty much hit the tail, original tail. We can still grab the next pointer. It's gonna point to the null pointer. Then we do the rewire, link rewiring. So that's changing this to looking like this. After this, when we actually do the advance, we're still able to do the advance, but for the next pointer, but after that there is no traverse anymore. But so let's just indicate that here. So we'll be able to know that we have already finished when our traversal node is null pointer. So if we have a while loop to do this rewiring reversal, the termination criterion for the while loop is going to be is the current node, traversal node, is null pointer or not. If it's null pointer, it means that we finished. And when we are done, the variable, the previous pointer is going to be pointing to the new head node. So we return that as the result. So with this kind of animation kind of thing, we should be able to code this iterative approach up and without any mistake. So let's just do that. So the previous is in the beginning, it's a null pointer. The traversal node in the initial case is the original head node. And the next node in the beginning, we don't know what it's gonna be. The loop, it's based on the traversal node. If it's null, we terminate. If it's not null, we still have some work to do. In the end, we should return this previous here. The logic for changing the rewiring the direction is to first to grab the next node. Then the rewiring is to have the traversal nodes point to the previous node. Then we do the updates. We move the previous first, then move the traversal second. Yeah, so with this example, manually worked through example, there should be no mistake in the code whatsoever. Alright, let's see if it works. Cool. So that's the iterative approach. With a solid worked through example, manual works through example, the code should be looking like this and no problem whatsoever. Let's talk about the recursive solution a little bit. So to think about node kind of a problem, like tree in either linked list or tree, usually we want to think about what I as a unit, what I need to do, and what I need someone else to do. Thinking in that way to help us to reason recursively. So obviously for a node here, the duty of myself, the thing that I can do if I know where I am is to ask my next to point at me. That's the job that I need to do. So this translates code is basically node. My next, I want to have that node to point to me. And so that's changing the that's asking 2 to point to 1. What I want other nodes to do is I want node 2, my next, to do the same thing. So it will ask node 3 to point to 2. And I actually want that to be done before me, before I ask 2 to point to me. Because if I ask 2 to point to me, then I will lose the 2 will never know that 3 is after him. So so it will lose that connection. So it will be ask my next to do the same as me. That's the first thing I need to do. The second thing is to this. So the first thing translates into code is just the function of node. I'm passing my next to this function, recursive call. That's pretty much it. The stuff that I need to do, and what I need to return is not myself actually, but my next. So this is the work I need to do, and this is what I need to return my next, or rather the stuff that I got from this recursive call. The reason being that if we're just looking at the node 1, it's going to be our entry point to this recursive call, recursive function. If we return the node itself, it will be the tail of the new, it will be the tail for the new reverse linked list. So definitely we want something that's further down there. So we would actually ask if this recursive function asks my next to do something. I want it to return something that he knows that I don't know. And node 2 or node 3, you will know node 3. You will ask the node 3 to do something, and so on and so forth. So the only in the red button to the recursive call, it finds the node 5, which should be the new node. So I should return this the node that's being found through this recursive function call. So that's that leads us to the base case actually. Base case, it's pretty much just gonna be 5 points to no pointer. Since that we are looking at the node 5 there, it doesn't make any sense to have this function call node 5 to call this on a null pointer. That doesn't make any sense. So instead of doing that, we should ask a node 5 to return itself. So if I have no next, I will return myself. So that if 5 returns itself to 4, 4 return that to 3, 3 return that to 2, 2 return that to 1, we will be able to just return 5 if we call this recursive function on node 1. So that's a reasoning there. Yeah, so it's pretty much this is the how the recursive solution is going to look like. The reasoning through the behind the recursive method. That's gonna yeah. Let's have two separate section here for both. Sorry, my brain isn't working today. Yeah, so with this node here, we should be able to code up this recursive solution with no problem. So yeah, we're just gonna call this function on my next. Ask him to do the same as me, and I will do this link swap, rewiring kind of thing. So we're just gonna be I'm going to return the node that I got from the recursive call. This function return this. And the base case is up front there. Let's just safeguard this a little bit. If I have a null pointer in the beginning, yeah. So if I'm a null pointer, or if I don't have any kind of nodes that after me, I must be the new head. So I'm returning myself to the function that calls me. So it's backward kind of relaying all the way back to the beginning. Yeah, so that's pretty much this. Let's see if it works. Okay. Oh, okay. There's one last thing here. I think I'm missing one big thing here. Have myself points to null pointer. So that is that is if I ask 2 to points to me, I will no longer need to point to 2 anymore. I will free up my pointer so that is that how? When I am node 1, I definitely want to do this because in the end I have to point, node 1 has to point to null pointer. But does it make sense for node 2 to do the same? Notice the order. Basically node 3 is pointing to it, and it points to node 3. So that's a kind of a cycle, but it's returning itself to node 1. And node 1 asks it to rewire 2 points to node 1. Yeah, so it doesn't hurt. So the node 2 will first change its next to a null pointer, but after that, node 1's function call would ask node 2 to have the the next pointer points to it. Yeah, so we need to do that. Okay. Yeah, so this should do it. Cool. All right, so that's this question in both iterative and recursive. Yeah, I think iterative it's a little bit more work in manually enumerating over the updating kind of procedures. Grab the next, rewiring the link, and advance further down into the sequence. A couple of place to notice is that in the beginning the previous node is the null pointer. We start with the head, and in the end we terminate when the traversal node is pointing to a null pointer. And one tricky thing I guess is to the order of advancing and advancing these 2 pointers. We have to move previous first, then the traversal. Yeah, so that's the code here, the 4 line to update this. For the recursive one, I guess it's already as easy as it could be for a recursive problem, but I'm still missing something here. Only after submitting a code that doesn't work until I start to realize I have this missed. Okay, so that's pretty much this question, how to solve it in iterative approach and recursively. I personally definitely prefer the iterative approach. If I'm on a whiteboard, this will be drawn in like 2 minutes or so. But typing this whole thing up, it's taking a lot of time. Yeah, all right. So that's the first question about linked list this week.